or speed of a reaction. We need to monitor few factors so we can optimize the rate of the reaction to obtain more products in less time. The most important factor may be in the case when a solid is involved. Okay, there is the surface area to volume ratio, particle size, contact area. Smaller the particle size, finely ground a substance is. Okay, it is powdered, it is amorphous, powdered. Okay, like talcum powder, it's flying. Then it means more collision frequency. And when there is high rate of collisions, the rate of successful collision is high, because reaction rate basically depends on what factor? The collision. And there is a collision theory as well, because we know that when reactant particles basically collide, their collision may lead to the breaking of the bonds. So they shatter into atoms. The lowest of the limit they go to of the size. But all collision may not lead to breaking of their bonds. Some collisions may be simply collisions, nothing, playful collisions. They are not at the right energy level. They are not at the right activation energy level. In the previous lesson, exo and endothermic reaction, you can find out on the same syllabus that in the lecture that how actually what is the role of energy. Simply mean they should collide at a required energy level. Their collision must be at a right energy, minimum amount of energy that can shatter those bonds, that can send them into atom form. It means their bonds are broken. So it means all collisions cannot be like that. So when there is frequency of collision high, rate of successful collision may be high. That collision which has led to the breaking of the bond. And once their bonds are broken, they release energy to the surroundings and then they remake the bond. It means the reaction rate increases. So the prerequisite is, if there is solid involved, it must be not in the chunks form, not in the big granules form, not granulated, not in the chunks form, if you want a higher rate. However, in some cases, if you are desired to, if the reaction or experimental situation says that chunks are there, mean you need slower rate. You need gas at a slower rate, or the reaction you want to proceed at a slower rate, maybe in some cases you use granules and chunks, because a bigger particle size, it means its only surface is exposed to the other reactant and inside particles are resting. They are waiting for. However, if it is broken down to smaller particles, it is amorphous, it is powdered, it means every particle has exposed itself and it is facing the other reactant. So if you want to improve the speed of the reaction, you want to maximize the rate of the reaction, you have to grind it down finely into smaller pieces. Grind finely ground, amorphous, powdered. Then you will write down this thing, the smaller the particle size, amorphous it is, more collision frequency, higher successful collisions and higher rate. Okay. That is why it is desired that you should have the mortar and pestle in the lab and you grind it down into chunks and all that if you want to see a rate of reaction, how it goes faster and how quickly the gas is evolved. Like in one case 5 grams of zinc is there, but excess of HCl, it means this is the limiting one. So the amount of the gas produced will depend on the zinc. But if there are two cases, one is powdered zinc and other is granulated. In powdered zinc, you find out gas produced should be the same because HCl is in excess and gas is being decided by zinc. 5 grams in both cases. HCl is in excess. Zinc is the limiting reactant. Product will depend on the zinc. But look at the same volume of the gas, suppose 60 cm cube, is produced very quickly here in the powdered form. You can notice the reaction is finished after just this much of time. This is time on the x-axis. This is volume. But in the other case, you note down, look at that, it has taken so much of the time, almost the evening. So it means factors, the most important factor that can improve the rate of reaction is the powdered form. Surface area to volume ratio, particle size, contact area. Smaller the particle size, more particles exposed at once, higher frequency of collision, and then higher successful collision. fruitful collision, and higher rate. You at least need to write these terms basically to show the rate of, show the factor affecting rate of the reaction. Which one is? The particle size. Excuse me. So the other important factor that basically is needed here, maybe the most important factor, there is temperature. Temperature, because higher the temperature, more particles gains activation energy. When temperature is high, more particles gain activation energy, because increasing temperature increases average kinetic energy of the particles. Most important factor. So when more particle gains activation energy, more collisions are successful. Higher rate. Temperature can be the most decisive factor. Here I am standing in this room, or you are somewhere, and it's air, and we know that air has what? Two important things: nitrogen and hydrogen. Nitrogen and oxygen almost makes 99% of the atmosphere. Why they are not reacting? Because if they react, they will turn to a toxic N2O or NO2, nitrous oxide or nitrogen dioxide. Poisonous they are. But thankfully it's not happening. Reason, the required amount of temperature is not there. Because if the sun starts flowing so much of the heat, or something happened to the ozone, or UVs too much, temperature gone so high, this may become possible that the nitrogen, which is very stable, need a very high bond energy, and oxygen, they may react. But it's not happening, thankfully. Reason, because temperature is not adequate. Okay, a very little amount may be formed and that got diluted and moves up, but it is not happening. Temperature, most decisive factor. That is why when sun shines, plants are saying thank you, because plants photosynthesis department is reacting carbon dioxide taken from the air and water from the soil, and their bonds need to be broken, their collisions need to be successful, their particles need an activation energy, and that can only be provided if the temperature is not there. Temperature is there. So sunlight increase means temperature increases and photosynthesis rate goes high. So that's why crops are ripening and fruits are ripening and all that activity of the plants and food is channelized. So where in the industries, temperature is a very decisive factor, that we need to heat many things to carry out a reaction. And sometimes the temperature is somehow checked out by catalyst. Catalyst decreases the activation energy. So at a lesser temperature, the reaction rate goes high. Even the plants got enzymes, which are basically the catalyst, biocatalyst. So that's why they are able to carry out the reaction. Otherwise, some reaction need very high energy. These two gases, nitrogen, oxygen, also face each other in a car engine, vehicles, but little amount of nitrogen dioxide is formed because very high temperature they need. Some reaction may occur at a very less temperature, but some needs high temperature. Food is cooked because you provide energy and collisions and successful collision and bond breaking. That's why cooked food has a different taste as compared to the uncooked. So during winters, plants are starving somehow if they haven't stored food, because sometimes the winters can be so harsh, the temperature goes below 10, the photosynthesis almost becomes standstill because required amount of the energy is not there. So temperature is very important factor. Simple thing to learn: higher the temperature, increasing the temperature, more particles gain activation energy and more collisions get successful and higher rate. However, if you decrease the temperature, you will find out that energy is depleted out of the system and less collisions are successful and less particles gain activation energy. less collisions are successful, lesser rate then. So temperature is another very important factor. A very important factor rather, the most important one is temperature. Reactions are temperature dependent. Most reactions are. Okay. So that is another factor we need to be careful of. Then effect of concentration. The factor is very important, especially when you are using solutions, when you are using liquids. And solutions means solute and solvent are involved. When solute and solvent are involved, normally the bottles contain the label. Like the one bottle may be 1 mole per dm cube of HCl. And other bottle may states 2 moles per dm cube of HCl. So when it is the word concentration, it means how much concentrated the solution is. Okay, if it is concentrated high, then it means it has more particles present in a certain volume. Less concentrated, less particles present in a certain volume. So concentration is a very decisive factor again. Okay, when we say it is concentrated, it means higher the concentration, more particles per unit volume. Higher the concentration, more particles per unit volume. More collision frequency. And when the collision frequency is high, remember why collision frequency is high? Because solution is concentrated and there are more particles per unit area. More successful collisions. Higher rate. So if you want speedy reaction, quick products, higher pace of the reaction, then remember, choose the solutions which got a higher concentration. Safety issue may be involved. Sometimes the concentrated solutions are so that reaction may be explosive, so we need to be careful in that case. But normally, if somebody asks you effect of the concentration, idea is clear. Concentrated solution, not dilute. When it is concentrated, then more particles are present per unit volume. More particles per unit volume mean more collisions. More collision mean higher successful collision. And higher successful collision ultimately leads to the higher rate of a reaction. And vice versa. Remember, if a solution is dilute, your wording should change. Dilute means less particles in a certain area. Less particles per unit volume. Lesser collision frequency, lesser rate of reaction. Example can be from the wars, old classical wars like Athens and Spartans, like those classical wars. Initially the war was so fierce because there were so many people involved. So many people. But later on, as the reaction proceeds, as the war proceeds in this case, people are dead, so the war rate decreases. Initially they was killing around. Same goes for the reaction. Initially you will find out a rate of reaction very high. The observation may be vigorous and violent, so much of the phase. But gradually the reaction settles down, less of the phase, less of the gas evolved. Okay, reason, initially the concentration is high. Number of particles per unit volume are high. Collisions are so much. When collisions are so much, obviously rate of reaction is high. So you can explain this factor always on the fact higher collisions are always coming from the solution which is concentrated, because number of particles per unit volume are more. So if it is concentrated, you need to look at this thing. Okay, and if the concentrated solution is also the decisive factor, the limiting factor, it means increasing the concentration will always increase the volume or the product form. However, if it is not the decisive or limiting factor, it will increase only the rate. The product amount will depend on the factor which is limiting, like zinc and HCl. If zinc is limiting and HCl you are increasing in concentration 1 mole, 2 mole, 3 mole, 4 mole per dm cube, only the gradient will get steeper. but the volume will depend only on the limiting reactant. So you need to be careful when looking at the reactions, that suppose they are like this, it means the factor you are increasing the concentration, the volume is increasing, it means that particular reactant is also the limiting reactant. But if the graphs are like they are finishing at the same point, it means this is dilute and this one is concentrated if the factor of concentration is involved. Even if the factor of temperature is involved, this is less temperature, this is more temperature, because decisive factor is, the limiting factor is the one that actually is involved with the concentration. Okay, so we need to be careful also for the excess one, which is limiting, whose concentration matters. Then effect of pressure. Remember, sometime an MCQ may state, or a question may state, which one of the following reaction is affected by the pressure. You need to be careful. The pressure, the press, only gases can be pressed. So it means that reaction should involve gases. So effect of pressure mean increasing pressure increases more the amount of particles. Increasing pressure, you are increasing in pressure, it means increases the amount of particles per unit volume according to kinetic particle theory, according to the reaction kinetic standards. Remember, sometimes the effect of pressure will be asked in the form of dynamic equilibrium, then we'll state different thing in reversible reactions, you can find out in that. But here increasing pressure increases the amount of particles per unit volume. Okay, as volume decreases, because there can be two situations, look at that, pressure is like this, but if you increase the pressure, it means number of the particles gone so high in that small volume. Volume decrease means more particles come across, more collisions, frequency higher, successful collisions, because all collisions, as we said earlier, all collisions are not successful. So higher successful collisions, higher rate. So if gas is involved or gases are involved, the pressure also come into the game. We need to be careful if we want to improve the rate of reaction, speed of reaction, whether it is a forward reaction or backward reaction, pressure will have equal effect. Remember, if it is even a reversible reaction, rate, reaction A plus B changes to C plus D. So increase in pressure will decrease in volume, more particles come across face to face. It means more collisions are possible, because gases, when they are at a lesser pressure, particles are far off. But if you increase the pressure, then the volume decreases, particles come across face to face, collisions, and collision is the prerequisite for a chemical reaction to occur, because all collisions are not successful. If you have decreased the volume, it means frequency of collision has increased, then obviously the frequency of successful collision is high. So rate of reaction basically is dependent on the fact that high pressure is needed. Forward reaction or backward reaction, rate will be increased in the same fashion. Pressure will have similar effect on a forward reaction and backward reaction if the reversible reaction is on. And if it is not a reversible reaction, then obviously the increasing pressure will improve the rate of forward reaction only, because it's only forward reaction. Okay, so high pressure, it means less volume, more collisions, higher rate. We'll see the last thing, that is catalyst. A catalyst lowers the activation energy provide an alternate route pathway. It lowers the activation energy, provide an alternate route or pathway. More particles are colliding at activation energy level. Higher successful collisions. Higher rate. So catalyst sometimes is extremely important, especially for the reactions which consume a bit more of the heat, maybe endothermic, or even for other reaction, catalyst plays a very important role. Okay, because catalyst lowers down the activation energy. Like energy profile may be like this. These are the reactants, gradual increase, and here they are colliding with the successful energy they needed. And then suppose it is exothermic, these are the products. So look at the activation energy this reaction needs. It means only those particles which climb up this level, their collisions are successful collisions. And then they shatter into the atoms. And then their bonds are broken. But if you apply a catalyst will cut down this energy hump. Check out. The energy is decreased now. That is needed for a reaction to occur. So catalyst has brought down that energy hump. Now more collisions, almost it has increased by 50%, and more particles are colliding because their collisions are getting successful and they are shattering into the atoms, their bonds are broken, and higher rate. So catalyst is very useful. It lowers the activation energy, it helps us save the fuel, it improves the speed of the reaction, almost improves double the rate of the reaction. Okay, lesser energy needed, lesser fuel consumed, product become more feasible because more it is basically value added in the sense of price. Okay, less of the fuel consumption mean less of the price in the market, and higher rate of the reaction mean more shipment are met in the less amount of time. So catalyst lowers down the activation energy and provide an alternate pathway. Catalyst may be both. Okay, catalyst may be inorganic catalyst, like iron is catalyst in Haber process, or nickel is the catalyst in hydrogenation, or catalyst may be enzymes, biocatalyst. All these plants are carrying out reactions which may not be possible in the lab. Reason they got super chemicals, proteins, the enzymes which makes those reactions possible in a sunlight situation. So catalyst lowers down the activation energy, but catalyst has no effect on what? Remember, catalyst has no effect on yield, or catalyst cannot have any effect on what? The enthalpy change, delta H. Remember these two important points, because catalyst cannot improve yield. Okay, it may provide a suitable yield in a less time, but it cannot increase the yield. Any question saying catalyst increase the yield? How come? Catalyst cannot provide these particles from its body, and catalyst has no effect on delta H, because delta H is basically the difference of energy input and output. So that ratio remains the same. Catalyst will only basically decrease the activation energy, or as enzymes they provide an alternate pathway, and then catalyst carries out a reaction. Catalyst may participate in a reaction, but in the end it is yielded as such. Catalyst never undergo a change in its chemical nature, remember. An MCQ may say that catalyst changes in chemical nature. No, then that is not the catalyst then. However, catalyst may change physically. Like you started with tablets and it has in the powdered form, and you started with powdered form, it may turn into chunks or granules. but catalysts are normally widespread, like catalytic converter. It is open, it can make, if it is open, it can make 2 football fields. So it provides more surface area for the reaction to carry on. Catalyst can be inorganic, can be organic, but the primary thing is it lowers down the activation energy, provides alternate pathway, makes those reactions feasible which were sluggish and slow in other situations. But catalyst has no effect on yield and delta H. Okay, so transition metals, they are the best catalyst. Like some in some question you can find iron or the word nickel or platinum or even transition metal oxides like vanadium pentoxide. They are best catalyst because of their high heat capacity. Okay, they absorb gases on the surface, reactants on the surface, and absorbing them mean weakening their bonds, and weakening their bonds mean their collisions are successful at a lesser energy. You may not know the mechanism, need to know the mechanism that how the catalyst, but just for interest, catalyst absorbs certain reactants on the surface, weakening their bonds, okay, like those surface catalysts. But important thing you need to mention is they lower down the activation energy, they provide an alternate pathway, and they makes more collisions successful in a lesser energy level. Okay, more particles gain the activation energy, lesser fuel consumption, mean they are basically making the process economical. That is about factors affecting rate of reaction.